Hi, good morning, good afternoon. My session title is Controlling Cypher Queries with Voice. I'm Koji Annoura. Let's start my session. I'm going to talk about a simple implementation of speech recognition. I'd like to talk about following topics. Who am I? About speech recognition. What tool do I use? How to implement it, and what to do next. I begin by who am I? I live in Japan. My name is Koji Annoura. I live in Fukuoka, Japan, south of Japan. I'm a founder of Neo4j user group Tokyo. Next meetup, number 36 with Lavus, Italy, at June 28th. And I work at UTI Inc. The company is Neo4j authorized distributor in Japan. I love community, two communities. One is Neo4j. I am a Graph Community MVP 2020 and Neo4j ambassador and speaker and ninja and developer. And I am a member of LibreOffice Japanese team. And you can find me here. One is Tweet of the Week, July 4th, 2020. And this week in Neo4j, just this week. You can find here, okay? Okay, and speech recognition. I'd like to explain about the speech recognition. Speech recognition is used Star Trek. Do you love Star Trek? I'm a Trekkie. In Star Trek, and the replicator can create food or other things. There is a famous word about drinks. Do you know Captain Jean-Luc Picard? He said, "P. Earl Grey hot," and Catherine Janeway, just coffee black. Pretty famous. Okay. When they speak to the replicator, a drink will be served. It's like a 3D printer. It's my this is my first speech recognition experience. In 1983, almost 40 years ago, before 1 year Macintosh, I use speech recognition for data entry election ballot. This is not good recognition, just number recognition. Okay. For example, 1,234, just enter 1, 2, 3, 4. Okay. And the pattern matching of number sounds. Training is like here, 1, 1, 1, 1, and 2, 2, 2, 2, 3, 3, 3, 3. Yeah, it's easy to training, but it's the machine very poor recognition. It doesn't recognize angry voices. 40 years ago, it's not good. Windows, now Windows many smart speakers. Smart speaker understands simple commands, just like alarm, set alarm for 9 a.m. something, message, read my new messages, and weather. What's the weather tomorrow or today or day after tomorrow? It's easy. And smart speaker and phone has wake word. Wake word. Apple, hey something. Google, okay something. Okay, Amazon has full wake word. Yeah, I like last one. Star Trek wake word is just one, just computer. Yeah, good. I want to implement computer is my program. Yeah. First, I'm looking for recognition tool. I brought about 6 typical tools. 6 famous tools. Please take a look at the table. Number 1, Web Speech API is free. Yes, the price is very important. And run on browser. 2, speech to text and not free, Google Cloud. 3, Amazon Transcribe, not free, Amazon AWS. And 4, speech to text, no, not free, Microsoft Azure. 5, speech, yes, free, by Apple, run on iOS and macOS. And 6, dictate, yes, free. It's by Microsoft, run on Windows. So I selected Web Speech API. Yeah, close. It's free, no API key, and easy to use, and run on JavaScript. It's like familiar, yeah. Recognition is not so bad. And cons, it is not W3C standard yet. Recognition is not so bad, but not good. You can see the documentation at GitHub IO speech -API. So first, I will show you a small demo. Okay, I talked this sentence. The data platform for today is intelligent applications, and the 4 words: node, relationship, property, Neo4j. Okay. Yeah, this is my, this is the first, yeah. That is a lot of languages and United Kingdom and United States, okay. Yeah, good. Oh, just all sentences and words correct. Yeah, U4J is UFOJ, but it's correct. Yeah. Web Speech API is JavaScript API. GitHub is here. GitHub wicz.github.io slash speech dash API. Web Speech API has two interfaces. One is speech recognition, asynchronous. Second is speech synthesis. This is text to speech. This time I use first one, speech recognition. Web Speech API run many browsers. Run Google Chrome, Safari, Microsoft Edge. I do not run Firefox. Oh boy. I want to run, I hope to run the API on Firefox and Internet Explorer. Yeah. You see the chat. Yeah. And like green color runs the Web Speech API, and current Chrome, Safari, and Chrome for Android, and Samsung Internet runs correctly. Share is 70. It's like a 70%. Yeah, good. Well, and how to implement it? Okay, let's take a look at language implementation. Bloom can do near natural language search. Okay, first one, Cypher. Cypher is easy to learn and human readable. And match person activity movie. It's easy to write, but it's not natural language. Bloom Bloom can understand near natural language, like Germans ordering seafood or customers from country ordering category. And a seeker, I don't know, too many giants, no one readable. Speech, it's good text. You saw my demo video. It's good, really good to translate it correctly. The long sentences, good, and the short, good. But I have trouble like Node 2021, Nodes 2021. Yeah, it is not Node. Nodes is not in the dictionary. So I test I 4 times Nodes 2021. So the text is does 2021 and knows 2021. And node 2021 knows 2021. It's not good. Dictionary is most important. Let's take a look Broom. Broom is simple structure, I think. It is made up of 2 main parts, just 2, search phase and Cypher query. It's really easy. So I use this phase and query like Broom. At Broom, speech movie title contains matrix. Such phase is like this. Matrix is to title. Fixed is movie title contains, and variables is matrix. It's so simple. I like it. So I test my application. Speak. Movie title contains matrix. Search phrase is the same. So I create from the speak languages to a cipher. Match movie where something contains a title written something as the title, but it's not work correctly. Its matrix is not matrix, and M is not large M. Yes, not little M. So I changed Cypher query. I used like this. It is same entry, but my Cypher query is different. Okay, it's not large. Okay, it's good for a matrix. M is large or small. It works well for two pattern. Like, let me show a demo. Start. Yeah, movie title contains matrix. And creates a cipher. Okay, it's easy. Okay, and New natural language search is, I think, good. Pros is light. It's not heavy. It's easy to create application. Okay, easy to implement. But cons, it is not a natural language. We need to learn how to say it. And knowledge graph are hard to implement it. It's not just pattern matching, so it's not use database or something knowledge. Yeah, it's easy to use, but it's not good. But oh, continuous questions. In the process of working on it, I found a series of questions. Questions are created from questions. You know, how many movies are there in total? What are they about? Blah, blah, blah. And in that case, or if something, okay, questions are created from questions. So I changed my application, and it's run continuous questions well. For example, speak, number of movies, 38, 10 titles. Okay, Cypher query is here. Remembers movies, a node, and 10 titles. So limit 10. And person name, speak number of person, 133. Speak, next speak, 20 names. And the Cypher query is here. Match person return order by limit 20. It's just 2 questions. But I have problem. So name is not good to correct, not so correct. Yeah. This is 5 speak, and one is correct. Brookie Lantong. Third one is third one, and one person is correct, but no, not man. Other person is not correct. Yeah, it's not good. So I choose number. Number is good, and ID or something person number you can use. For example, shortest path 10 and 2, 10 and 12. 10 is Billy Crystal. 12 is Brookie Lantern. Good. A little bit. I have a real problem. 1, 2, 3, and it's change 1 to 3. So I 1 and 3. I changed to and, okay. So I speak shortest path 10 and 12. Answer Cypher is Cypher query is here. My application creates the Cypher, match person Billy Crystal and match person named Brookie Lantern. Oh, and shortest path. Oh, it's easy. And this is a graph, a shortest path. Yeah. What to do next? It is under development now. So advanced continuous questions. So for example, 3 questions I have. One is movie names include matrix. One question, Q1. Q2, movie name include Cloud Atlas, Q2. So Q3, who are the actors in Q1 and Q2? Okay. My application remember memory Q1 and Q2. Yeah, and we use with previous questions. And to the next schema, read schema to good dictionary. Node name, label, property name, and relationship name include in our dictionary. Yeah, it's good to translate. And I want my application to graph apps. Yeah, it's easy to convert. Graph apps is single page application and HTML run on JavaScript and run the next Neo4j desktop. It's easy to convert. Okay, sum up. I create a small application with speech to Cypher query, web speech API, about 70% of browsers. And about API has 2 parts, speech synthesis and speech recognition. Speech synthesis is good. I want to use return value like a count. I want to use. And continuous questions. Questions are created from questions. And the number is a good answer.